solve the differential equation and I want the domain. I would always get in a habit of thinking about the domain, even if you don't always have to answer it, always think about it. You'll see that on AP packets. A lot of times they will answer with the domain even when it's not asked, which leads me to think they're planning on starting to ask it more and more often. So if I were you, I would always think about domain. The newer questions ask it often. The first thing I need to do is separate the variables. I imagine you have done that by now. At first, it's easy to separate the natural log, but you do end up, if you leave it, you have xy dx. How would you get rid of that y? Divide. And then how do you anti-differentiate that left-hand side? Use substitution. In fact, I think that is straight off of a gateway, isn't it? I think so. I'm going to let you be what? So sometimes we will still need a U substitution. This is anti-differentiation. If we need it, we use it. Whatever that may be to get the antiderivative. So I have the integral of u over y times y du. Luckily, the y's cancel, and I get 1/2 u squared. U was natural log of y, so I get 1/2 natural log of y squared equals negative 1/2 x squared plus c. The right-hand side was much easier to anti-differentiate. The left-hand side I needed to side note and do a u substitution. I want to find c, so first thing I'm going to do is plug x and y in. So this one's a hard one. Got a lot of exponentials and logarithms and fun stuff. What happens to natural log and e? Cancel, so I just get 2 squared, which is 4. 4 times 1/2 is 2. So c is 2. And so now I have 1/2 natural log of y parentheses squared equals negative 1/2 x squared plus 2. I do want to get y by itself. The first thing I would do is multiply everything by 1/2. I mean 2, thank you. Negative x squared plus 4. Take the square root of both sides. Anytime you take a square root, you do get a plus or minus. I can stop right now and decide which one of those I want. What was my initial condition? When I plug in a 0 for x, I get a positive e squared for y. Everyone agree with that? Which one of those will make that work out? The positive, correct? I thought about it. I'm picking the positive.
I'm kind of confused on that.
So plug in 0 and e squared in for x and y right here. Is it equal if this is positive, or is it equal if it's negative? You see what I mean? Now, if this had been a negative e squared, then I would pick the negative. E raised to both sides. And you could have made that decision later, but to me, I'm just going to go ahead and make it when I have to do a plus or minus. Go ahead and make the decision then. So that is my equation. I have my differential equation and I have my solution. Remember, I have to think about both of those when I'm thinking about domain. What are the three big problems with domain that we have? Okay, and what causes undefines?
Fractions, square roots, and logarithms.
Fractions, square root, logarithms. We have all three of those things. Yay! We have a fraction, we have a natural log, we have a square root. Logarithms can't be negative or 0. Square roots can't be negative. And and denominators can't be. Thank you. So just from the top, y has to be greater than 0. Everyone agree with that? Just from the top. And y can't be 1. How in the world did I get that? What is natural log 1? And why can't that happen? 0 can't be on the bottom. So I know this is what y can't be from the top. That is not domain, that's y. I need to know what can x be, but I'll keep that in mind. And then this square root can't be negative on the inside, correct? So those are the three things I have to keep in mind. One thing that's nice is e to any power ever 0 or negative? So is y ever 0 or negative? So I don't actually have to do any work to compensate for that. It just is. Y is just greater than 0. I don't have to worry about it. So that's nice. So now I just have to focus on y not being 1 and this inside being positive. What would make y equal 1? If this thing were 0. So that makes it where it's not that much more difficult. I just need to make sure the inside of this is greater than 0. Normally I would say greater than or equal to, but because of the natural log being 1, I'm going to say just greater than 0. It is a quadratic. I can factor it if I want to. You can do a sign chart, you can do whatever you want to do. What would make that greater than 0? Opposite of what you just said, I think. Between negative 2 and 2?
Greater than negative 2, less than 2.
Yes. Does everyone agree? Do I need to work that out, or are y'all doing that in your heads? I can work it out.
But wouldn't it always be greater than 0? Because it's a negative.
So 4 minus x squared greater than 0 is what I need. 2 minus x, 2 plus x. So if you're doing a sign chart, you put the negative 2 and the 2 on the sign chart. If I pick a number less than negative 2, like negative 3, I would get a positive times a negative, which is negative. Positive, negative.
Why do you get a negative?
Where? Out here?
Yeah.
Negative 3 plus 2 is negative 1.
Oh.
Negative times a positive gives me a negative. Or if you did negative 3 squared, you would get 9. 4 minus 9 is negative. So either way, you pulled.
How do you know it's supposed to be greater than equal?
What can you plug in square roots?
Oh, so how do you know that minus x squared is with the negative isn't with the x? You know what I mean?
Like inside a parenthesis, they would put a parenthesis.
But that's our word. So how do
we would put a parenthesis.
that whole thing?
The negative sitting out in front, it's not inside the square. To make it inside the square, we'd have to put a parenthesis. And it was, see how it was out here? Now, Alexis, that's why we did greater than or equal to 0. We do need to talk a little bit. Did you miss why it can't be 0 also?
I didn't really understand.
Okay, so you know why it's got to be greater than 0, because square roots can't be negative. Then if we look up here, we said y couldn't be 1 because that would make this denominator 0. If this exponent is 0, what's e to the 0 power? And y can't be 1.
Oh, because it's e to 0.
On the top. So that's why we're just strictly greater than 0. So my domain is from -2 to 2. And this is actually a typo. Those -2 to 2 should be parentheses. -2 to 2 is the domain. So that one was about as hard as domain could ever get because we had like 3 things going on. So I did a really tough one for you. Let's do this AP practice problem. Has nothing to do with domain. How do we, after that one, do we feel a little better about domain? No, yes, no, maybe. It was a bad one. They aren't all that bad. I have myself a little reminder up here to ask about the math competition. Some point in the near future, if you want to go, I'll need to know your name and that you want to go. When's the date on it? Was it March 5th? Is that what I told you? So if you're wanting to go, think about that. I think the deadline is next week sometime, and I will be asking soon. So, and remember, there are practice tests on UCA's website if you want to win. So what are you doing first? Okay. Separate the variables. So I get 1 over y dy equals secant squared of x dx. And then what? Before that, integrate both sides. You see why I made you do that master exam? You have to know everything from here on out that we do. You have to know those integral rules. What is the antiderivative of secant squared? And then find c. When x is 0, y is 5. What is tangent of 0? So c is natural log 5. E raised to both sides. Because this is a multiple choice problem, you probably don't even have to decide between the plus and minus. You notice they're all positive up there, so they don't even give you that question. Since y is 5, it would be positive. But this answer is not an answer. Good. There's a reason I keep showing you this. This is like the 3rd example that we've done in class where we've had to use this property. Y'all remember this? You can break up addition in an exponent by doing two pieces with multiplication in between. E and natural log cancel, and so I get 5 e to the tangent of x, which is so I get the question a lot. As soon as I say in calculus class, on open response, we don't have to simplify. Why do you keep making us simplify on homework? Is the question I always get. Well, why? Multiple choice, we've got to match these very simplified answers. So we still need to do the practice, even though we don't have to do it on every open response. We're going to stop there. Tomorrow we're going to do some applications of differential equations with exponential growth and decay. And then later this week we will do slope fields. So those are the things that are